Yes, it is visible now.
Thank you. So good afternoon, everyone. And it's my pleasure to be here and covering some thing which I'm very, very passionate about. And I've been doing this for more than 30 years now. As an architect and as chairman at Capricorn Technologies Private Limited, we help all the users like yourself in the construction industry understand the technology. So I'll just take 10 odd minutes to explain why is BIM important for us and especially for CPWD. So, so the biggest challenge we are facing on this planet is we human being ourselves. And I'm sure all of you would remember this date, 15th November last year, as a human population, we have crossed 8 billion people on this planet. So this is a global number. Of course, we are in India and we are more worried about India. And as a country, we know we are somewhere around 142 crore population. Our population has been growing. And let's take a very simple example. Okay, that what is the impact of this population growth to us in the construction industry? That's what why I'm showing these numbers. So let's take a very simple example and presume, let's say we are as a human, as in Indians, we are growing at about 1%. So the fortunate part, as you can see in the graph, we were in fact in 80s and 90s growing more than 2%, but it has now reduced to about 1%. So let's take a simplistic figure that we are about 142 crore and we are growing at 1%. So which means what? That we are growing, we are adding about 1.2 crore Indians every year, or in approximate about 40,000 Indians are getting added every year. So that's the number of Indians increasing. Now, which in terms of as being part of the construction industry, it translates that we need to construct for each of these Indian which is born a home, which means around 8,000 to 9,000 homes are required to be constructed every single day of the year. So look at the quantum of problem we are facing in our country, that we need to construct 8 to 9,000 homes every day of the year. And this is just the number of homes, but we also know that you can't just construct a home. You need to have a lot of other infrastructure, like I need offices, I need schools, I need hospitals, I need transportation network like roads, metro, we need water supply, drainage, and all the matching infrastructure which is required in a city. So that kind of highlights the quantum of work we need to do to provide a good livable space to every Indian being born. And how will I solve this problem is I will I will say very naturally that I will increase my speed, I'll increase my productivity, and I'll be able to deliver for that. But the statistical data done by various research doesn't support that. And in fact, what we are seeing, the trend in construction industry is not same as many other industry. Like, let's take an example of manufacturing. If you look at the blue graph, manufacturing industry has been able to improve the productivity of the people working in that industry, but somehow construction industry has not been able to do that. So that's our second challenge. The first challenge is a demand, that we have a huge demand. But to fulfill that demand, I have somehow not been able to improve the productivity of the people responsible for delivering that demand. And then the third problem is the expectation. Now, many times when we, as an architect, especially when we look at our buildings, we say, oh, historically, so good buildings were done. But and in industry, so what has happened if we compare with them, like let's look at three phases: pre-industrialization, industrialization and what is expected today. So before industrialization come, most of the buildings were done by a lot of effort and handwork, and they were very beautiful buildings. Quality was also very good, but maybe in terms of affordability and making them again and again was not so common. And that is the problem which industrialization solved. In industrialization, we have buildings and all other products which are very functional, comparatively affordable, and we are able to mass produce them. But today, and I'm sure this is the challenge each of us is facing as part of the construction industries, that our client are asking best of everything. They want building to look very beautiful. They want very good quality. Obviously, it has to be functional. They want us to reduce the cost of each project. They want to make it very quickly. And of course, post-pandemic, one of the most critical challenge which has been now added to every building, and that's everyone is talking about net zero, climate and everything, that each of the building is also sustainable such that the pressure on our Mother Earth is reduced. So this is the expectation. So there is a very high expectation from every corner of what we deliver. So that's the challenge. Now the solution, how do I solve this problem? And for that is what we are presenting here today is we need to use digital technology. And as we, in fact, today G20 is going on in the country. And one of the biggest thing as a country, we are presenting that how as a country we have used digital technologies to solve a lot of problem we are facing and how the lot of inclusivity has been done. So similarly for our construction industry, we need to use a digital technology, which we are calling as building information modeling. So BIM has to be used to solve our construction related challenges. So the question which comes is that what is BIM? Is it a software? Is it a technology? Is it just putting the building information, or is it a process? What is BIM? And for that, let us try and look at some of the definition of BIM. Now, for my explanation purposes, I have divided this definition into two parts. So this is first part, and there is a second part. So let me go to first part. So in the first part of definition, we are saying building information modeling, BIM, is a digital representation. So the first thing we are saying that it is a digital representation. So as soon as I start representing my building using any digital tool, it could be AutoCAD, it could be SketchUp, it could be Revit, it could be any other software. As soon as I start representing my building digitally, it is kind of BIM. Making a drawing on paper is not BIM, but as soon as I use any digital tool. But then what do I represent? So it is a digital representation of physical and functional characteristics. So what I need to do in that building model is reproduce physical and functional. So let me explain what do I mean by that. So what I should be able to do for a building is I should be able to represent the geometry. That's exactly what we do traditionally on a hand-drawn drawing, and then later on in AutoCAD is we draw plans, elevation section, and what we are doing is we are representing the building geometry. But then in BIM, I should not be able to only make geometry, but I should also be able to represent using building components. That means instead of drawing lines, arc, circle, I should be able to make walls, doors, windows, column, beam, slab. I should be able to have all building components. So which means like if I draw a wall, I should say this wall is a brick wall plastered with whatever plastering material or cladded with whatever cladding material. So I should be able to make building component, specify the material, and then if I draw four wall, I can say there is a space inside this, and this space is used for office, or this space is used for residential, or this space is used for storage, or it is used for any other activity like that. So I should be able to identify the space and this then say what kind of occupancy that space is going to have. And then I should be also able to say what performance do I need from that space? What temperature do I need? How much of light do I need? How much of air changes do I need, or any other parameter which I want? So this is what I should be able to make in my building model. So that's my first requirement from a good BIM solution. But how does this help me? How does putting all this information in my building and making that building model is going to help me? And what I should then be able to do once I make this building model, I would be able to do various kind of analysis. Like if I say, okay, this is a building and this is an office building, and I'm putting this office building in New Delhi. If it is in Delhi, I should be able to identify how much of heating and cooling load would be required in this building, or any other kind of analysis, how much of light is required, of how much of nowadays, how much of solar energy can I produce here. So I should be able to run those kind of various analysis. Then I should also be able to simulate various things. What if I rotate this building by certain angle, will it increase or reduce my heating or cooling load, exposure to west side or east side? How can I change the size of window and see what is the impact on my heating or cooling load or light condition required? I should be able to meet various kind of statutory compliances. My height regulation, how do I look at that? Is my fire safety distance sufficient, etc.? Air changes are sufficient or not? And then that's why I should be able to explore my building and finally give a very optimized design. And so after doing this building, then this same data I should be able to use for my operation and maintenance. So this is what I need today from a BIM, and that's what a good BIM software will offer me. But this is more about a building and physics and other parameters of the building. But we know designing and constructing a building is a process, and a very complex, time consuming process, like from the program to conceptual design to detailed design, etc. And we have to take a lot of decision in that process. And today what is happening, because of the complexity, lot of decisions are to be taken, and it takes a lot of time to take this decision, and as a result the projects are getting delayed. So another important requirement is that how can I speed up? Number one, how can I speed up this process decision and bring all my stakeholders onto one single kind of a page? Can I bring all the stakeholders together and they can work on it? And in the long term is, once I start digitizing this information, it will also become something like my shared knowledge. And as today we hear a lot about big data analysis, we talk about artificial intelligence, we talk about machine learning. Now that all will only become applicable once I have sufficient digital data. So this will also help in future to improve my buildings as I capture more and more information. So a BIM is basically a two-part. One, creating the build, and second, improving this entire design process itself is where my BIM is going to help. Is there any question anyone asking? Okay. So basically, I can say that BIM is now becoming an environment in which we are going to design and construct the building. That's basically what BIM is becoming. And one of the very critical factor today, what we see in a traditional design process, most of the time is going in detail engineering and documentation. We spend a lot of time in detail engineering and documentation, creating construction documentation. But what we want, and as an engineer, as an architect, we know if I get more time to think about design, I can actually give a better design. And that's how BIM is going to help me, that it will give me a lot of time to spend on design and improvement in the design. And then documentation will kind of automatically happen, or if not fully automatic, semi-automatic. It will automatically create the documentation in a much faster way, as we'll see in our subsequent presentation, that preparing 2D drawings, taking out quantities, etc. is so easy in the software. So because of all this, what we are seeing throughout the world, BIM is becoming mandatory by various organizations, and in some countries, even at a country level, they are saying that we must be using BIM. Of course, it is not easy. And they have learned that you cannot just say BIM, you'll have to have an intent, you have to have a policy, and then you have to have processes around that. So therefore, what they have creating is a roadmap. Okay, we will go to level, today we are at 2D CAD, we will first go to level 0 of BIM, then level 1 of BIM, then level 2 of BIM. So like that, they have created a long-term plan in which they are increasing the maturity. And exactly same thing is happening in CPWD. You have started many years ago by saying that we want to do BIM. And as we are getting into more and more details, more and more defined processes and methods around BIM are coming. So basically, we have to leverage technology for design using BIM. Similarly, in construction, we are improving I'm sure everyone is aware about lean construction processes, which is helping improve the construction on the site. And the projects are being now delivered using integrated project delivery, which is bringing a lot of people together. So with that, using all these digital tools is what is helping us in improving our projects. So with that, I'll hand over back to our team to take up on more detail.
Thank you so much. So now we get to even more exciting part of the session. So now we will cover the practical demonstration of how BIM works. So for that, I would hand over to Shoaib. He's going to work with his team on role playing on a real life. I would not say real project. It's a demo project, but how in a real life project starts from architecture, then structure, and MEP, and then finally design coordination for an optimum design management in a BIM environment. So for that, Shoaib, over to you.
Okay, thank you so much, and good afternoon, everyone. So I'll share my screen. I think my screen is visible.
Yes, Shoaib.
Okay, thank you, sir. So now I'll introduce my BIM team and we'll simulate the process of how how a project is delivered on BIM. Just a minute, yeah. Our project is delivered on via using BIM technology. So our design team would majorly consist of a design coordinator, and then under that, different discipline teams used to work. That is architecture team, structure team, and building services team, majorly covering MEP services. So in our case, these are the people who are role playing today. From the architecture side, I myself, being an architect, I'm role playing as an architecture consultant. My name is Mohammad Shoaib. Then from the structure discipline, Vatsal Singhal is role playing as a structural consultant. From building services discipline, Tanveer, he's a mechanical engineer. He is role playing as an MEP consultant. And similarly, after completing all those, models, we'll send those to our design coordinator, that is Tushar, who is role playing as design coordinator. And later on, he'll create a federated model. He'll club all those discipline models together and run a clash among them. So without a delay, I'll start the role play. So I'm covering the architecture discipline. So as an architecture consultant, this is me. And starting with any project, we usually we architects usually start with conceptual design. So I'm going with the conceptual design. So BIM ecosystem has a lot of softwares. So this software is for conceptual design. And here we can simply start by setting up the location, or we can also start from scratch by creating a building form. So I'm starting with setting up the location first. So I'm going for the location. Under that, it actually allows us to pick up location anywhere, either by putting up coordinates in degrees and minutes, or maybe we can write down the location, such as I'm writing down, let's say, Gurugram. So it is showing me some results. I can be more specific, such as sector 62 Gurugram. So I'm getting similar results. Or otherwise, if we have a location on, let's say, Google Map or Bing Map, we can just put up the coordinates and it'll grab those coordinates accordingly. So now I've set up this site, this piece of land as my site plan, and I can just simply import not only the image which is shown here, for reference, I can also get the terrain data out of it. That is, for the contour creation. So I'm just clicking on this import satellite imagery and terrain, and it will allow me to pinpoint the area, and also to set up the building context. If I would like to include, let's say, adjacent building to show the entire neighborhood, I can just zoom out and can set the area accordingly. So I'm just setting it up to this level, for example. So I think this much would be fine. Okay, once it is done, I can just finish importing. It not only imports the site context, that is the terrain layer. So as you may notice, since it is Gurgaon, so it doesn't have that much of contours. But if you are working on hilly regions, it will show you the exact terrain which is there. Anyways, so I'm switching off the terrain layer for now. So it has multiple layers, and now I'll start modeling over it. So to start with that, we can use multiple unit systems. So usually multiple consultants works in multiple unit systems. So BIM ecosystem supports multiple unit system. So for example, if architecture consultant is working on, let's say, feet and inches, and suppose meanwhile structure consultant is working in metric system. Similarly, let's say MEP consultant is working in another metric system, maybe meters or centimeters. Then since BIM ecosystem works in 1:1 scale, we may switch in between at any time. So I'm starting with meters, for example, and I'm just creating some shapes here. So you can start with 2D lines like AutoCAD or any 2D software, or maybe you can start with directly 3D shapes. So for example, if I put up a cube here, I can just select this cube. I can stretch its faces to any shape. And I can just maybe get a form out of it. And then later on, I can also play around with this form. For example, I can interact with its edges. I can also interact with this with its corners if required. I can replace the edges with another edge, and I can get different shapes out of it. If I, for example, like to draw on the faces of these edges, that is also possible. So it is quite easy in that sense. For example, I've drawn this portion here, and I would like to push this portion away from this part, and a new possibility has opened up. For example, something like this, and I can do that on the other side. Anyway,
sorry to interrupt you.
Yeah, sure.
Let's go a little bit slower. There are some internet problems, some people's issues. Let's try to go a little bit slower in audio and in video.
Sure, sir.
Thank you.
Sure. So in this case, okay, I'll try to be a little slower. Okay, so like I started with the shapes, we can start with different shapes, or we can start with lines also. So most of you, I think, are already familiar with CAD-based softwares where lines are being done. I'm also starting with, let's say, a simple square. So I'm starting with the square. I can, by idea, can draw on screen and can take decision, and I can also put up exact values if required. Like, for example, I'm putting up the exact values in this case. So it's a building footprint of, let's say, this size, 13 by 71 meter. And I'm going for, let's say, 5 stories. And so I'm taking around 15 meters of the height. Similarly, I'm just creating another shape here of the similar size. So you can go not only rectangular, you can also, if required, can go for other shapes as well, such as circular or any other interesting shapes. Anyways. So I'm taking kind of similar building in this case. And obviously, not only like linear buildings, you can also, rotate them as per your requirement. So all of that features are here. And an interesting thing is that this software supports, touchscreen iPads and all as well. So if you are, for example, if architects are, because most of the architects are prone, are used to working with sketchbooks and all, so you can also, put up your, sketch sketching skills to the software by using it on the iPad. So it is also iPad compatible. So anyways, yeah. So now suppose these are two building blocks, one slightly, rotated, and these are both, let's say, connected via a some corridor. So I'm just, trying connect it with some corridor. And suppose this corridor is not of full height. It has got some, passageway below it. Suppose there's a 3 meter or 3.5 meter passageway below it so that people can pass under it. So this is the conceptual form. So once a form is completed, you can maybe put up material to that. For example, I'll just show some material capabilities. So it has, bunch of materials available already. You can also create your own material. For example, if we need to put up a concrete facade, let's say, so suppose one of the sides is of fully concrete. So this entire block has been converted to a concrete block. Obviously, we'll go side by side. So I can also, get into different materials. Suppose the surface of this side is concrete panels. Let's say precast panels are to be placed in this case. We can also change the size of the material as well. Anyways, but you got the possibility here. Similarly, since this building form is created for 5 floors, keeping in mind, depending on that, you can also add, multiple levels to it. So I'm adding, let's say, levels in this case. Suppose first level, I'm adding at height of 0. Okay, another level I'll add at 3.5 meters. It is fine. You can also change the height from here. Suppose if you need to change the height. Similarly, another one is going for 7 meters. Now I'm keeping rest of the levels at 3 meters each. So I'm just keeping it at 3.5 plus 3 meters, that is 6.5 meters. Similarly, I'll add more, that is 9.5 meters. And let's say another level at 12.5 meters. Right. So first story is 3.5 meter, rest are 3 meters each. And now we can assign those levels to this entire thing. I'll just simply go to its properties and can assign levels to it. Just a minute. And as soon as I assign those levels, you may see the level marking in the conceptual model. And also, if I select one of the elements in the form, you may notice that each level is showing its area. So it is showing in square meters. Suppose if you want to change it to another unit, that is, let's say, feet and inches, then again, you just need, it's a one click away, and you can just simply select the components. In this case, building forms, and their areas are shown in square feet, as you may notice. So these are the levels, and their areas are shown. So this is that dynamic in this case, right? Similarly, if I need to also set up a target area to achieve, to calculate FAR properly, because that is we architects needs to take care to cater FAR. So we need so to cater building bylaws, I mean. So to ensure building bylaws, we need to keep track of FAR, floor area ratio. So this software gives us that capability. So we can put up, let's say, areas, a site area in this case, and target area, and gross area is automatically calculated. That is on the basis of form we create. So in this case, I'm putting up the site area, which is to be designed for this particular site, that is 484 square feet, not meters, sorry. This dimension I had in feet, so I'll just simply change it. Just a minute. Okay. And then target area, I'm setting up to, let's say, 880 square feet. So it is now converted. Sorry, this part I need to again fill up because it is just updated. So whatever site area you have, you can just fit that. And then you can also feed the targeted area which you want to achieve. such as in this case, this is the target area, that is about 20% of the site area. That is what FAR allows me for this particular region. And automatically FAR is being calculated in this case, right? So you can keep track of it. For example, if I make changes now, suppose if I reduce the height here, suppose, and as you may notice here, FAR is being started to reduce. Similarly, if I, for example, increase the height here, so accordingly, suppose it's a large building, then accordingly FAR starts to change. Just a minute. Sometimes it takes time to update, but yes, it updates automatically. I need to add more levels in that case. So earlier it was 0.19. Just a minute. So for example, if I reduce it, you may notice the change in FAR, that is 0.17. And if I now change it back to the original height it was, so it will be around 0.24. For larger building, we need to add more levels. So as per addition of the levels, the form whichever we are creating, we can also track FAR accordingly. So once a basic form is created, you can also run initial level performance analysis, how our building is going to perform under sunlight, under different weather conditions. So when I set it up this location, this location not only sets up the context of the site, it also sets up the weather location. So in this case, as you may notice here, it also sets up the weather station for us. So not only we sets up the location in context of the project, we also set up the weather data, which can be later used for energy analysis or HVAC analysis. So in this case, if I need to run initial level solar or shadow analysis, I can do that. But to do that, I'll just change the visual style. I want to keep it as the monochrome surface so that we can see the shadows and colors properly. And now I'll just, similarly, you can also, change different visual styles. It does have different styles available for the presentation purpose. So I'm switching on shadows, for example, and also the sun editor. As you may notice, as soon as I switched on sun editor, it is allowing me to simulate the sun location in my project. So in this case, this sun, this is the symbol of sun. It is at 12 p.m. I can just simply drag the sun manually, and as you may notice, shadow is being tracked in this case. This is how, if we are working with multiple buildings, for example, we can also identify the areas which are darker throughout the day, and we can plan accordingly if we need to get sunlight at every area, or if we need to keep some areas under shadows. So similarly, if I, for example, also run solar analysis, I can choose date and time accordingly, and accordingly solar analysis will be started. So for example, I'm taking, let's say, today's date and time, although we usually, obviously, we always design it for the future, but I'm taking for the month of, let's say, June. June is fine for me. So for the month of June, but this year, so 2023, sorry. So you can write it down, or you may also choose the year accordingly. For some reason, it is not updating, but no issues. So sometimes this takes, I think okay, no issues. But anyways, this weather data is kind of similar for the entire year. You can change the months and dates accordingly, like I'm changing here, right? So by using the slider, and for air, you need to obviously change it from here. Then similarly, we can also change the time from the slider as well, or maybe manually choosing the sun. So for example, I'm keeping it around 10:30-ish a.m., or maybe I can keep it around 3:30 p.m. That is the peak hour for the sunlight. So that is the most sunlight usually. I'm testing it for the month of June. That is maybe this month. Yeah. 3rd June, and I'll just hit solar analysis. It will start collecting data accordingly and allow me to run solar analysis on the monthly basis and yearly basis. So I'm going for monthly basis in this case, and I'll just select the surfaces where I want to run the solar analysis. I've selected the entire project. You can also select, phases. For example, I only want to, let's say, run solar analysis for this phase individually. Then that is also possible. For example, this phase is crucial because it is going to, let's say, place some glass on it, and I want to, decide if glass needs to be more reflective or less reflective. I also want to, suppose need to decide the type of glass according to the SHGC value of the glass, how much it takes the solar input. So we can also again decide for a particular surface as well. So I'm just running the analysis, and as you may notice, it is falling under this region. That is, 0 to 147 BTU per square feet only for this surface. And similarly, we can select the entire model and can run solar analysis for the entire project. Right. So I'm selecting the entire project again, resetting it. I'm selecting the entire project and running the analysis for the entire project. You may notice that different surfaces are highlighted by using different colors for different months. I can also change months from here. So in the month of March, we get lesser sunlight. For February, even lesser sunlight. For the month of obviously November, December, even lesser sunlight. If I go for May, June, July, we'll get most sunlights at the roof and similarly on the facade. We can also get it for the airs. So I'm moving within months. I can also get the cumulative. That is, average sunlight for the entire air. So this is how you can also decide at the very initial stage if the orientation of the building is correct or not. Once decided, you can just simply, push this model to detailed design software. This is the conceptual design software. So I'm just saving this. So you can save it at some locations. I've already saved it. So I'll just show you the almost completed model. This is the model where we have, terrain and satellite data already available. So accordingly, that satellite data, all those levels can be transferred to, let me save it. No issues. I'll save it again. So this was from yesterday's input. I'll just save it, let's say, on desktop for today. So conceptual form I've just saved. And now I'll go to detailed design software. So BIM ecosystem has, like I said, multiple software. So this is the part of the collection. And in this case, you can just simply use that same model to do the detailed design. Although this software not only supports architecture part of it, it's a multidisciplinary software. I'll just show you the basics of it. You can choose multiple, templates out of it. These are some predefined templates. You can also create your own standard template where you can choose as per your discipline. So if you're a mechanical engineer, you can go with a mechanical template. If you are doing entire MEP, then you can go for systems template. If you're an electrical engineer, you can go for electrical template. Similarly, architecture, structure, and construction template. So I'm going with the architecture template just to show you the overview. And if you notice here, okay, it is opening. And if you may notice here, it has multiple discipline tabs such as architecture tab, structure tab. So it supports multiple discipline. The architecture tab obviously allows you to do architecture modeling in this software. Similarly, structure tab allows you to do structure modeling in the project. And for structure detailing, if it's a steel detailing, then we have steel tab. Similarly, for precast projects, we have precast tabs. For MEP, we have systems tab. Under that, we have HVAC panel for HVAC design. Similarly, mechanical panel for further detailing of the MEP components. Then plumbing and piping for piping. And this is the electrical panel, which will allow us to do the power design and lighting design. So in this case, if I, for example, need to start a project, let's say from scratch. So there are two approaches to any project in this software. You can maybe start from scratch, or you can take up the conceptual form, which I just created in another tool, and can proceed along with it. So if, let's say, I'm taking the example, if we are starting from scratch, so we can just simply start by placing, let's say, grids or levels. So in this case, if I go to some of the elevations, so it's a 3D software, so it contains, elevations, plan, section already. So if I, for example, put up the heights in this case, let's say another 4-meter height. So I've placed 3 levels in this case, level 1 and 2 and 3, and I can just go to similarly floor plans of each level. As you may notice, there is nothing created yet. I can put up, grids for a project. So suppose this is the first grid I'm putting up. Then let's say at every 6 meters, I'm putting another grid. And this same grid can be used by other disciplines as well, such as suppose structure engineer needs to place grids. They can also use the same grid, or maybe they can put up the grid in this file and can send send it to the architecture team. So both ways it works. So usually, structure and architecture teams work in collaboration. Anyways, so suppose this side I'm going for, let's say, 8 meters of gap. So these are some grids which I have placed, and similarly, I can now start creating walls for the architecture purpose. If a structure person is working, then they can start with the structure columns and structure components, which I in the upcoming session Vatsal will cover. Anyways, I'm going with the architecture wall, and suppose this wall is starting from this level and going up to the level above. So I'm going for up to level 2, and I'm just placing few walls here, right? After placing walls, I can just simply, place interior walls, and suppose the assembly for interior walls is different. So in that case, we can choose another wall from the given list. If we need to create our own interior block work or interior partitions, or maybe for exterior walls also, we can simply, modify these components. It has properties which will allow us, for example, if I choose one of the interior blocks, which is 100 in this case, you may notice it has got the preview for it. And it has got 3 layers in this case. Like it has, concrete mesh in between and gypsum on both sides. Similarly, we can go for wooden partition or glass partition if required. Anyways, so we have the choices to, choose the material at the initial stage also. And if later, we can also modify these assemblies as and when required. For example, these are a few rooms which I've placed. I can just simply, control the visibility of the layers. So these are different layers. So I'm just keeping the grids layer a bit lighter, so that I can focus on these wall layers. And as soon as I'm creating all these walls, a 3D byproduct is also created. So this is the 3D view. As you may notice, I've just turned it into shaded. So 3D is also being created side by side. And I can also, for that matter, keep it side by side. So I'm just keeping side by side window, 3D on the left hand side and 2D on the right hand side. So like we used to work in AutoCAD, we used to work in 2D. So similarly, I was working in 2D view, and 3D was automatically being created in this case, right? So suppose now if I need to add, let's say, doors and windows in this project, I can just simply go for door tool. I can simply place a door here, choosing one of the sizes from the door, or I can also load it from the library. I'm just keeping a door here. Similarly, I'll just keep one door at this end. Similarly, to enter this room, I'll keep a door here, and for example, a door here. So as you may notice in 3D view, doors are automatically being placed. Similarly, we can also put up windows if required. So obviously it is required in most of the projects. I can just choose the size of the window, and I can just simply place that. So you may notice here, the door which is placed in plan view is showing a 2D line additionally, which show the swing of the door. Similarly, windows are also showing the swing of the casement window. But if I check it in 3D view, it is showing the 3D preview of that. So in this BIM ecosystem, software is smart enough to change the representation as per the view. So in plans, mostly we create floor plans, and as per floor plan graphics, it automatically updates the component. And you can also control the graphics as per your design standards. Suppose if you in some offices, if you need to show this opening line of the door in dotted line, then that is also possible. So this is the default which I am showing. Similarly, we'll place more windows, and accordingly it will allow me to. So this is so we actually work like an AutoCAD in this case, and a little more automated, like we place blocks in AutoCAD. Similarly, we are working in the same manner, but a 3D is automatically being created. Not only 3D, if we need to cut a section, for example, through it, I can just simply go to view and can choose any new view to create. Section is one of an additional view for this BIM software. So I'm just creating a section. I can also control this section direction and its extent, to what extent I want to check my section. I can also rotate my section. Sorry. I can also rotate my section if required. So single section line can also be used for reviewing the entire project. Anyways, so I'm going to this section view. So it accumulates all its views at one place, and this is the section view which can be seen in this case, right? I'm turning it into shaded. And if, for example, if I make changes in the section itself, suppose if it is the case, I need to make changes in the section. I've selected I realize, suppose if I need to, for example, shift this door to the left, I can just simply select the door in the section also. Not only we need to every time go to the plan, it is automatically selected in the plan view, the same door, and also in 3D view, as you may notice. And if I shift it to the left by using arrow keys, it is as simple as that. Or maybe you can use proper move tool, and you can just specify the dimension. Suppose I'm moving it by 3 meters, and it moves accordingly, right? Or otherwise you can use move tool. So anyways, so in this case, 3D and as well as in 3D and also in 2D view, this door has been shifted. This is that door, right? So I hope you got the idea that this ecosystem allows us to create views which are connected with each other. So if we are making any changes in the 2D view or 3D view or any section or elevation, subsequent views will automatically update. Not only this, it also allows you to get quantities and all. So the rest we'll do in the project which we brought from the conceptual design stage. So this is how you start from the scratch in this software, or maybe you can get a conceptual design model from other team, or maybe from the senior architect, and then you can also keep on moving towards that. So I'm using the same template again, that is the architecture template, and I'll link that conceptual model into it. For linking, I'll just simply link it like a CAD file. So I'm just going for that, which I just need to change the format. So in this case, I created this conceptual building form, right? And I'll just simply open it. Import units in that case would be feet and inches. So we can also, work with dynamic units. I'll just open this. And as soon as you notice it placed here, if I switch to 3D view, you may notice that, and if I turn it into shaded or maybe realistic, that site context has also been brought here. So the site which I chose for Gurugram, and along with it, its contours are also brought into it. So for now, we are not, going into the site development detail, but yes, you got the idea that that entire thing can be brought here. So anyways, I can still control its layers, which we created there, such as the satellite imagery layer. If I apply it, it will be switched off, and the terrain layer, it will be switched off accordingly, right? So this is the layer where our component is created. Now, what we can do, we can pick up its edges. Suppose I'll just simply, I can also create levels in this case, obviously. So I'll just hide, I'll just switch off layer of terrain in this view as well. This is the elevation view. And there are 2 levels which are already placed. And the first level was 3,500 and rest were 3 meters each. So it was created in such a way. So there were 5 levels, right? 5 stories, basically. You can put up dimensions as and when required, and also make it print ready. So if I turn it into shaded, this is the basic mass. If I need to convert it into actual, building forms, such as, let me go to another elevation to properly manage its levels. So these levels are overlapping with the building form. Anyway, it's a very small thing, but you can accordingly adjust it. So if I adjust it in 2D view, it is also adjusted in 3D. Earlier it was overlapping. Anyways, so now moving ahead, I can simply go to again plan view for this conceptual design form. Suppose I'm choosing the site plan, and I can simply go for again building components such as wall, and can pick its surfaces and lines. So I'm just choosing the type of wall which I'm going for. Let's say in this case, I'm going for some kind of a brick wall system, and I can just simply select the edges. And as you may notice, these edges are being converted into walls, right? And later on in 3D view or in 2D view, we can control its height and all, right? So suppose if I go back to 3D view, in this case, these walls which I just added, and I'm just connecting them to the entire levels, like from level 1 to level 6. So these are those brick walls, as you may notice, because that was the intention to place it. And then I can also place roofs and all. If, for example, if you need to place some glazing, so we have the options to, switch between. So I'm going with, let's say this time, glazing wall. So we have options available. I can just simply select the edges of it, And as you may notice, a glazing wall is being selected in 3D also. So you can work in 2D as well as in 3D if required, right? So suppose the height of it starts from level 2 and it is going up to, let's say, level 5 in this case. Right? So accordingly, we can adjust. Similarly for this side also. It is started. So this is the kind of connecting corridor in this case. And so entire design can be, so you won't lose anything in the process. Usually when we switch from one software to another software, we lose a lot of data. In this case, since all of these tools are of same BIM ecosystem, so whatever we created in conceptual design tool is now brought here and further detailing is done. So I've already created the model completely. So I'll just simply switch to the model. So we have added, few doors and windows and few, elements into it. So obviously you have already seen how to place windows and all. But if you are into, for example, although not everyone is into programming, but if you want to make your software to automatically place many things. So if you want to run an automation in your design, in that case, you can also take help of the software's capability of handling the basic programming. So if you, obviously, this is not for everyone. If you want to place your windows and doors manually, that is also fine. And that is how most of the people work. But if you want to get more output out of it in lesser time, you can also automate the process. And to automate that, obviously, I've just recorded few sessions for automation. So in this case, this is how a script of automation looks like, right? So this is the automation script. So obviously those who are interested can also learn later. So what we did, we actually picked up all those walls which we created and divided it into multiple panels, and then we placed windows in between. And we got some panel options in this case. So these are different options which we played around, and this is the simulation of the process, right? So you can also run multiple design options into it. So for architect, this is a challenge that we produce 3 or 4 options to the client, and sometimes it takes a lot of time because a lot of rework is done. But by using some automation tools which is already available within this BIM ecosystem, you would require some programming knowledge, and then you can also run the design, multiple design iterations out of it. This is the simulation of that. So this is how I actually came up with these facades. So we especially for this white one, we actually ran those simulations. Anyways, so this is the completed project. And like I mentioned, we also place internal walls, and these are the floor plans which can be shown in this case of the same project. And this is the architecture part of it. So obviously there's a structure part of it, which later Vatsal will cover, and MEP part of it, that is, another person will cover. So in this case, so we also get reminder for saving the projects in between, and it's a good thing. So I've already placed internal walls. I've also placed text in between. We also can use it for tag. Like I showed in elevation, we can also put up dimensions, and this entire project is, this entire floor plan is kind of ready. For more, presentation sake, we can also add colors to it. So for example, if I need to add colors according to the spaces which are placed here, such as this is the game room, this is the unit 1, this is RA unit, it's the laundry area, this one is the toilet area. So we can also, color our areas as per the name of the rooms. So that is automated in this case, which we architects usually take help of, maybe hatching in AutoCAD, which sometimes makes our model heavier and makes our, CAD drawings heavier, or sometimes we take help of another software such as Photoshop and all. So anyways, so I'm just going for placing the color legend. So you can just simply choose color legend. In this case, I can, assign a scheme to it. So example, I'm assigning its scheme as per rooms by the name. And accordingly, automatically colors are being filled. You can also, choose color to be more darker or more lighter according to your requirement, or can use another color from this swatch. So now I'm satisfied with the lighter tone of the colors. I'll just accept it, and once I accept it, our entire floor plan will be colored automatically. So it is calculating, and once it is colored, a legend with colors and our entire room. Oh, sorry, I think I just mistakenly switched off the layer of the colors room. Just a minute. Yeah. So now I'll switch on the room colors. because I was experimenting with this model. So I mistakenly switched off the color fill. So we have different layers like in AutoCAD in this software as well, and I can control the sub layers of that. So I'm just going with the color fill of every room. It is now updating. And I'm showing everything live here. You may notice that. So as you may notice, the entire corridor has been highlighted by the yellow color. Is similar spaces are highlighted by similar color. That is all. So it's a housing project, basically students' housing, hostel type project. So all rooms are actually added by some blue color. Game zone is highlighted by some other color. Similarly, toilet areas are highlighted by different colors. Fitness center, community room. So you got the idea. So similar rooms are actually colored with same. So this is the backend AI which is working in this case, and it is quite easy to do that. And anytime if you want to change it, you can just get to it's editing the scheme. And not only by the name, you can also color your rooms by the area and other properties as well, such as area. I'll just show you briefly. It converts to the area, and now different areas, similar areas will be colored similarly, and different areas will be colored with different colors. So it is again recalculating as per the areas, and it will show you all the, it is going live. So it takes, a few seconds. And as you may notice, as per area, it is showing. You can also set up the range for the area, like 8 meters, 8 square feet to 12 square feet, 12 to 17 square feet, or 100 to, so something like that. That is also possible. So rather than going by value, you can go by range as well, right? Anyways, so for now, I'm just keeping it by name. But I'm just showing you the possibility which are available in this ecosystem. So once it is done, you can also put it on a sheet. It is now recalculating according to the names. I just changed it. Yeah. So now once it is completed, I can just put it on a sheet. So to create sheet, we can just simply, take our standard title block. So if you, in your company, obviously you have your own sheet format, you can take up any sheet format and can place there. I think I've already created a sheet. In this case, I just need to place it there. So you have so many sheets in this project. Just a minute. So this is the sheet which I created, and I can just simply drag and drop that floor plan view. So it is under the floor plan, and this is the floor plan which I was working on, right? Floor plan overall. So I'm just simply dragging, simple drag, and I can just drop it on the space of the sheet. So it is as simple as that. We do not need to get into the make viewport or something similar command. It recalculates, and we can just place our sheet, we place our view accordingly. Once placed, it will start showing the preview. So this is the viewport which is automatically placed. So I hope you got the idea. Now we are ready to print it, and we can also export it into a PDF or something, some other format if required. Interestingly, we can also export it into CAD format. If, for example, there are organizations, they still accept CAD drawings, we can also export it into the DWG format, and also in the PDF format, or maybe we can directly print it from Revit. So this is the part where drawing creation is covered. Now, for example, if we need to get the quantities out of it, such as maybe door window schedule, or how many doors are going to be placed, what is the type of furniture is to be placed, so we can just simply create a door window schedule out of it. So this is just a database for the software. It can just give us data in the form of table as well. Not like we may get data in the form of like 3D view or 2D view. We can also get data in the form of a table. So that is very simple for the software. So I'm just simply going for schedule and quantities option, and I'm just choosing the category for which I need to get the schedule. For example, I need to get door schedule. So I'm just creating door schedule for, let's say, first floor. So I'm only sticking to the first floor. Suppose you can go for multiple floors at a time. So I'm just going for first floor. This is the first floor drawing which I'm showing you. And if I, for example, so as soon as I chose the category, I can choose the properties of the category, such as what type of door we are using. What is the mark of the door which we are using? So what is the width of the door? Such as we can also go for height of the door. These are door related properties. If I had chosen, let's say, column, we would get column based properties. If I had chosen, let's say, wall, for getting the schedule, we would have got the wall based properties. So whatever category we choose for scheduling and getting the quantities, accordingly properties will be shown. So I'm just choosing this much, and let's say I'll also take the level on which the doors are placed. So I'm just sticking to, let's say, filtering out. So I'll just show you the result first. This is how the entire table will be shown. I'm sticking to only, I'm filtering out only first floor in this case. That is the plinth level, right? So there are plinth level, first floor. Okay. So actually, I intended to go for first floor in this case. And okay, there are first floor levels available. Okay. So I'm just simply adding the filter for a particular level. Suppose level equals to first finish floor. Yes, this one is I want to go for. And you may notice these are first floor doors which are shown in this case. Similarly, we can also add more fields there. Suppose if we need to add cost and all, we can get the cost out of it as well. So suppose I'll also sort it as per. So this is how we use Excel. It's a kind of, there are many features of Excel which are inbuilt in this case. And then we can also, export it into Excel when and if required, right? So itemizing off color. Yeah, so this is how the entire, these are the types of doors which are placed in this case. So you got the idea. Similarly, we created, multiple schedules already. So for a project, we can get, multiple schedules. So we already have, let's say, a ceiling material schedule. So this is the ceiling material. So these are 3 types of ceilings which are placed in this project. This is the east wing door schedule. So we have also segregated door schedules. This is the east wing third floor schedule. This is the west wing door schedule. So there are 2 wings you have already seen in the conceptual design. So the idea is this is how a detailed quantity can also be taken. And this can also be placed on a sheet, and you can also link it with Excel or any other external format. So that was all from the architecture side. So now, so yeah, one thing I forgot is the visualization aspect of the software. So from the architects and the interior designers, it is also expected to get 3D views out of it. So we not only created 2D views out of it, that is present in the form of presentation drawing or working drawing. We can also get quantities you have seen. We can also get visualization. So these are some of the views which are shown here, and these are rendered with the help of Twinmotion. Twinmotion, I think some of you might have heard. Now Autodesk has collaborated with Twinmotion, and Twinmotion is now available for Revit as well. So these are those views. So where do you find that option? You find that option, you set up the view first, such as this view, and you go for this rendering option, and you can just push it to the Twinmotion. So just to save time, I already rendered it. So these are some of the views of the same project. So now I'll not take further time. I'll just start the role play for the structure, and I would like to invite Vatsal Singhal for that purpose. So Vatsal Singhal will be role playing as a structure consultant now. So Vatsal, I think over to you. You can start the role play for the structure modeling.
Okay, thank you, sir. I hope I'm audible.
Yeah, yes, you are audible.
Okay, so I'll just share my screen. Myself, Vatsal Singh. So I'll be role playing as a structure consultant.
Sorry to interrupt. Before
Yes,
you
sir.
start, one message which I wanted to give to all the participants. So there was one more session which was scheduled for Sunday, that is tomorrow. But as per the discussion with organizers, that session has been cancelled. So we will have the next session now on Monday on the same topics. So we request that you all the officials that please to your colleagues, or if you want to attend the sessions again, it will not be held tomorrow. It will be held from Monday onwards. Yeah, Vatsal, you can continue.
Okay, Vatsal.
Okay,
I'll stop sharing. You can share your screen.
Okay, so as Shoaib sir was explaining about the architecture discipline, now we'll just come to the structure discipline. So for the structure discipline also, we have the entire tool set over here. We have the beams, columns, walls. In case of structure walls, architecture walls too are there. The floors are there, different types of floors. The architecture floor is there, trusses, brace system, everything that is required in the structure is there. Apart from that, when you come to the steel connections, so steel connections are also there in this basically in this part. Also in the foundation, you have the isolated footings, wall footings, the slab footing. So if we just start from a basic part, suppose this is a rebar model that we've created. So suppose we have to just a second. Suppose you have to place any foundations or any columns. I'll just show you how you do that over here. So if I just go to the there are different levels again over here. So this is a small model in which we've done the rebar. Apart from that, there's also a model that we were already working on. So I'll just show you how we do the basics over here. In the foundation level, I'll just show you how you can directly place any footing, column, beams, that's it. So I'll just make another grid over here first. So I've just created a grid over here. On this grid, we'll basically place a footing and a column and some beams. So if I just go to the structure tab, I have the option of foundations over here. This slab foundation, basically the raft foundation in case you require any raft foundation. So you can directly just sketch any type of foundation. Suppose it is a L-shaped foundation or any other type of foundation. If I just draw a raft over here, suppose somewhat like this. So you can directly make this too. So if I just finish it and I just go 3D, so you'll see this is kind of a raft made over here, foundation slab. So we can consider this as a raft. Again, let's go back to the foundation level and I'll just show you how we have the capability of placing all the structure elements at one go. So if I just go to the isolated footings, so we have different options where you can like give different sizes of the footings. Already there are 2 inbuilt sizes over here. So you can either use these, or in case if you have any other sizes, you can do that too. Suppose if I go to the edit type property over here, so the thickness can be changed. So I just change the thickness. Suppose the width over here is 2400 and the length, let it be as 1800 only. So if I just take the foundation, I can place it over here. Likewise, I'll just place it on all 3 grids. And if I just go to 3D, so you will see all these 3 foundations have been placed. Right. Apart from this, also the same way we place the foundations, we can also place the columns. So I'll just take the columns. Rectangular columns are there. Again, you can change the sizes of the columns. You have different options over there. So these are the structural columns. You also have the architecture columns. Those do not have the structural properties. Basically, these are the structural properties which can be rebarred. Right. So I've taken a column size of 300 by 300. From here, we can also give every like depth and up to which level we want to take the column. So I'll just take the column to suppose say to the plinth level and then just place it over here. I just show it to you again. So you'll see this is the column that is placed. Okay, so now it's actually going just below the level. So I'll just give an offset of 0 over here. And I'll just change the top level to plinth level. So you can see we have placed the footings, we have placed the columns. Likewise, the beams can also be placed. Let's just go to the another level. And beams also, again, you can take different sizes of the beams as required. Right now, we'll just place the size that is available over here. And again, everything is placed properly. So this is how we can do the basic structure modeling. Also, you have a different template for structure. So if I just go to the template option over here, I take a new project. So there's a different option for the structural analysis default metric. Likewise, we had for the default metric, likewise we have for the structural options also. So we can use this and we can have the structural properties. So I'll just close this. I'll get back to the model. So this is a small model in which we've done the rebar option. So we've rebarred the footing, the columns, we've given stirrups also in the beams, we've given the stirrups and the main reinforcement. Apart from that, the proper column reinforcement has also been done. So I'll just show that to you just a second. Okay, so this is a model that the raw model that we have. So in this, if we start, we'll just go to the foundation level. So we'll start with the basics. We'll get a section of the foundation first, a horizontal section and a vertical section, so that we can directly place the reinforcement in the footing itself. So we'll just cut 2 sections and we'll just go to the section ones. So over here, there are different properties. You can obviously change the scale of the annotations that are there. Also, there are different modes at which you can see the rebar. So we'll just select it and we go to the options that are there for the rebar. So we have multiple options of rebars. The shapes, there are multiple shapes. Apart from these shapes, we also have shapes that we want to include ourselves it's not like by default we only have the Autodesk shapes that are there. We can also sketch any type of shape that we want. So it's not compulsory to use these. So I'll just select it again, go to the rebar option, and I have the sketch option over here. After like taking the sketch option, as I said, you can give different options for the rebar. Like I'm taking a 12 rebar over here. You can also take 16 and you can give different inputs for different sizes for the rebar. So after just doing this, we'll just sketch the rebar. Fine. So after just sketching the rebar, we have to segregate it throughout the foundation. So we have different spacing options where you can give a spacing accordingly. If you want to give a spacing of 150 or 175, in this case we've taken a spacing of 150 Also, we'll have to make it visible in the 3D since it is only view specific. So as you can see, it is placed in 3D. So as I said, due to the different viewing modes, you can change the visibility of that. Suppose you want to see it in a single line, or if you want to see a solid bar, so you can change the visibility options too. Again, we'll just change the scale and so over here, again, in the vertical section that was there, I have placed the rebar. So let's just go to 3D to check. Yes. So it is entirely placed over here. Right. Same with the column, since column is being cut through a horizontal section that is our levels. So I'll just take you to the NGL level, and over here we'll place the rebar. So just select the element and we get the options. All options are there. All capabilities are there to place the rebar. Any type of shape, anything that you want is there. By default, as I said, there are some shapes. So the stirrup shape that we require is by default present in these. So we can just select it from here. We can give the input. So I'm taking the 8 bar over here. 8 stirrup bar basically. And I'll just come over here and place it. Right. So again, we need vertical bars too in the column. So I'll be placing a 16 vertical bar. So we'll be placing 16 vertical bars over here. So I'll just show you the process, how it's done, the capability of that too. So we can also edit the shapes that are there by default over here. These shapes that we had, we can also edit them. So let's just, there are different viewing options also, as I said. So I've placed this bar. Now, if I just go to the 3D option again, I'll obviously have to turn these on in the 3D too, since as I said, this is view specific, very view specific. So in every view that you want to see the rebar, we obviously have to turn that through the visibility states that we have over here. So we'll just go to the 3D option. And over here, you can see a single bar has been placed along with a single stirrup. So this layout rule helps you to segregate these in different parts. So as it is 100 over here, I'll be giving 175 instead. We've given a 150 spacing over here. Here we'll be giving a 175 spacing. So I've given a 175 spacing. Also, this bar needs to be turned. So as I said, the default bars, the rebar properties that we have over here can be changed, right? So I have this bar, I can change the shape of this bar. This is an inbuilt bar that is there in the software itself. So I'll just drag it down and I'll turn it at a lap of 300 So I'll just draw it. Also, these bending curves are by default available. We don't need to like give proper curves and waste our time in that. Again, we'll go back to the NGL level, and over here we can just segregate it again using the rebar set. If I just show you, this entire column has been read, right? So we've now gone to the first floor level so that we can place the rebar at the above level too. So again, there are a lot of options that can be like used to place, like it becomes very easy. It is very like, it is flawless. So you can do anything very easily over here. You can place any types of bars. If I just take you ahead. So again, we've placed the stirrups, we placed 6 bars. So let's just view it in 3D. Okay, so as you can see, these bars again have been placed, the same ones that we did. Now, obviously, there is a lap over here. Again, it can be L by 3, L by 2, whatever the requirement is there. You can extend these bars that are there at the bottom, or if you want to extend the ones that are there at the top, you can extend these two. So just go to a specific view and use the extend option. So any bar property can be changed, any extents can be changed. It is like very easy to do that, and it becomes very sufficient. Also, it helps us in the bar bending shift. So likewise, we did in the footings, in the columns, we can do it for the beams too. So a section for the beam has been cut, and in the beam part we again place the stirrups. Yes. So after placing the stirrups, again we need 16 bar. We will take that and we'll just place it on the edges. Again, 16 bars are being placed over here. So you can start by placing one, and then you can use the layout option, use the fixed number option, maximum spacing option. As it is required, then you can directly just mirror it so that these are available at the other end, right? So we'll have to, like, this is a process, so we have to follow it again and again. We have to make things visible in different type of views. That is very important for us. So if I just take you over here, now since we've modeled everything, we've done everything, we've modeled one footing, we've modeled one beam, and we've modeled one entire column. It's not like we have to repeat this process again and again. We can just use the propagate option. Okay, so first what we'll be doing is we'll be also using the rebar option in the wall. So for the wall, we have the area reinforcement option. So this entire area can be reinforced at once. So if I just check the area, see it is properly like within the wall or not, align it if required, and then we can just finish it. Again, it needs to be visible. So we'll go to the visibility states again. Okay, so this rebar, this wall has been rebarred properly. It can be a retaining wall or a structure wall. Wherever it is required, it can be used, right? So as I was saying, we have the options over here. We have one footing option. Now we can use this footing and place rebar in the entire portion that are there. So if you could see, this is a bigger footing, this is a smaller footing. But with the same layout rule, we can use the propagate options that are there, and we can place it in the entire footings that are there in the project. Also, it's not like specific that if you place it on the other footing, so the size would remain the same. You can also change the spacing for that specific footing easily. Likewise, for the columns, you can just select the rebar in the column, and you can just select all the columns that you want to place the rebar again, and it will be done. Also, apart from this, if you want to change the layout of the reinforcement that is there, suppose there are 6 bars of 16 right now, you want to place 8 bars. So you can go to the layout rule and you can place 8 bars instead. It won't hamper any other column. It would only change for that specific column and no other column, right? So this is how the rebar is being done, and this model has been like finished easily in like within 10 minutes, where it takes a lot of time to do that manually. And since we have the automated system over here, it is done very easy. So if I just show you the final result. So this is the model that we have, that we're just seeing. In this, we can also give the color codes according to the requirements. So like over here, for the 12 I've given a red color. For the 16 I've given a blue color. And for the green ones that are there for the 8 I've given the green color. So you can also give color codes accordingly. You can change colors. Suppose this is a green color right now. I want to suppose change it to yellow. So I go to the visibility graphics option over here, and I'll just select yellow color instead. So as you can see, this is changed to yellow. So there are yes,
sorry for interruption.
Yes,
we
sir.
can move forward a little bit.
Yes, sir. Sure.
Thank you.
Okay. So this rebar option that is there is like actually done. Apart from that, we can create schedules. Suppose you require bar bending schedules. So I've created a rebar schedule already over here. So as you can see, this is a schedule that is there for the column. So I've applied a filter. I'll just remove the filter first. So you see wherever you've placed bars, you get the entire schedule. There is the host category. It is being placed in the structure columns or it is placed in the structural beams, structural framings, walls, whatever is there in the model, we get everything over here. Apart from that, we have the bar diameter, the bar length. This is a single bar length. This is the bend diameter wherever the stirrups are being bent or the bar is being bent. That we've fixed it to 50 mm right now. It can be changed accordingly. The quantity by rebar. So there are suppose 10 sets in a bar of 1950 mm. So the total bar length is again changed to approximately 20 meters. Then we have the bending detail. Bending detail, I'll just show it to you in the sheet. Also, we've calculated the total bar weight. If I just filter out again the columns over here, I'll just take the column. So I'll take the host category that is equal to structural columns. Okay. So if you see, we've also calculated the total bar weight just by using a simple formula that is used in the industry. So if I just show that formula to you, we've taken the bar diameter square and we've divided it by 162.28. That is probably the density of steel. And we multiply it by the total bar. Then this is being used to like cut the units and make it unitless. This is the further process. So this is the basic formula that we use in the industry to calculate the bar weight. So over here, almost all the bar weight is calculated and we have the grand total over here that is being used in the columns. 8 mm bar is of 256 kgs and this is of 875 kgs. The structural column bar, the 16 mm bar, and the total is 113. So accordingly, as you can see, the length is also calculated. If you have the weight per length, that can also be easily calculated over here. Okay, so I'll just take you to the model that Shoaib sir was working in, and I'll just show you some steel connections over there. So, okay, before that, there was this bar bending schedule that we created. So over here, if you see, along with the shape, we have the dimensions that are required. This bend diameter of 50 mm is there. This length is 310 mm and this length is 3120 mm. For the entire schedule that we created over here, the rebar schedule that we created over here, we have the sheet created for that. And we have the entire bending details that are required on site. So you don't need to create a bending detail for each and every detail. This is by default created by the software itself. So it saves a lot of time for us, right? Okay. So just give me a minute. I'll switch back to the model.
Meanwhile, Vatsal is switching the model. One important note here that all the data which you see, all the schedules, all the bar bending schedules, everything is connected to the model. So anything which is changed in the model will automatically change in the schedule itself. So as an engineer, you don't need to worry about the outputs. And any modeling changes will automatically change the schedule also automatically.
So as I said, everything is automated. Everything you do in the model is directly changed in the schedules. Like it was being changed in the plans, sections, elevations, it is being done the same way in the schedules as well. Okay, so we have this model over here, the model that we were already working on. This is a structure model for that. So in this model, there are usually or mainly there are steel connections that are there. So we have base plate connections over here. There are clip angles over here. There are these tube plates over here. So we can place these plates accordingly. I'll just delete some of them and I'll just place them for you from scratch. So suppose I'll just delete these 3 plates. So if I have to place a base plate over here, I just have to go to the steel option and we have the capability and we have almost all connections that are required. So I'll just show you the connection list over here. Okay, so if I just show you the connection list over here, almost all the connections that are required in the industry are present over here. So you can just select any one of these, load any one of these, and you can use them in the model. So likewise, we've just loaded these connections and we can use this in the model. So if I just select this over here, I just select this column, you can see this is a white flange column and this is W10 into 33. So if I just select this, I go to the steel option and I have the connection option. So since I said we have loaded the connections, we can directly place base plates. So there is a base plate that we can place. So this is a base plate that we placed. So if I just select this base plate, it will also show which input element is there. So which element is being connected through this base plate. So you can place multiple base plates like this by just going to these options that we have. Right. So we have placed the base plates over here. Also, we require clip angles over here. So we require clip angle for this column as well as for this beam. So we can just select both of them. And again, since we have loaded already the clip angles over here, so we have these clip angle, 3 vertical bolts, 2 angles, 2 unequal angles. All of them can be catered easily. So if I just press OK, so this has been placed over here. I'll just show it to you over here since this is being cut through a tube. So I'll just select this column and again the beam over here. So there's a connection that is created between these two. And again, if you just see over here, there is the input element. There is for the beams, that is there W16 into 40. And this is the W10 into 33. If I just select this, these are the two input elements that we have. Likewise, for this tube that we have a connection between these three elements. These three elements over here. So this here is the major element. So I'll just select these three together and I'll create a connection between these. I'll just create a generic connection first so that I can create and manage the main objects that are there. So this right now, this beam right now is being treated as a secondary option over here. And this tube is the tertiary option over here. So I'll just make this beam as the first option, the primary object. This as the second and this as the third. So if I just go to the connections option, I have these options for connections. So this connection has been placed at the beam. So if I again just select it, I have all three options, right? So that is how we can place multiple connections. So if you see, we've almost like created all the connections that were there in the model. And this is very easy to do, very flawless to do. In case you require any custom connections, we can also create custom connections. You can learn that later in the advanced part too. So there are different fabrication elements, modifiers are there, parametric cuts if required are there. So this is being done that. Okay. Now, if you see, this is a model that has also concrete elements. So in case if you have to calculate the quantities for the concretes, I'll just show you just a second. So I've created two schedules. I've created a floor schedule and I've created a wall schedule. So if I just go to the wall schedule, so there are different concrete walls. I'll just remove the filter once. Okay, so there are these walls that are there. There are CMU walls of 8 inches. There are concrete walls of 16 inches, 20 inches. A lot of walls are there. Suppose we want to calculate the volume that is being required for the walls, the concrete volume that is being required. Since we also have to like calculate how much cement, sand, aggregate, all these are required. In case of RMC, we required the total volume of concrete. So we can calculate that easily. If I just go to the filter option, I'll just filter out, say, the 12 inches wall. So I've filtered out the 12 inches concrete wall. I have the volume that is calculated as 99.79 meters square, right? If I want to change the unit, I can just select the entire column and I can change the format unit from here. I want it in cubic feet. So in cubic feet also it is calculated. The area of the wall is calculated. You know the width of the wall, you know the length, the entire length of the wall. So likewise, everything can be calculated very easily. Also for the floor schedule, if I just show you, this is the floor that is 4 inches concrete. Again, if I just go to the filter option and remove the filters. So I'll be having a lot of floor options that are there. There is a precast floor. There is a 12 inches plank plus 2 inches topping floor that is there. but we only want to calculate how much concrete is being used in the 4 inches concrete flow. So we can again just filter out all the, as Shoaib sir said, all the properties that are there in Excel. We also have them over here. So we can just filter out the 4 inches concrete. Also, if required, we can also like transfer this data to the Excel. That can also be easily done later on. So we have the volume. Again, as I said, you can change the format units easy. Right. Now, after creating the schedules and everything, the main part that comes into consideration is the working drawings. Right. So if I just show you the working drawings. So we can create the entire working drawings over here. These are tags. This is a tag option that is there in this software by default. You can directly place n number of tags over here. You don't need to like create any issue with that. So I'll just duplicate this. I'll just show you how we can place tags. So this sheet is blank right now. I need all the beam tags or the framing tags over here. So for that, I can just tag them all together and I have the framing tag option. So you can see all of the framing tags have been placed at once. You don't need to like select everything, write text over here. It gets done within a second, right? So we can also transfer this data to a sheet in case we want to print it. So we have the sheet ready for that. So this can directly be printed onto the sheet, right? So that is all from my end, from the structure end. I'll now just introduce you to our okay. So now Tanveer sir will be carrying on with the building services option. So he's a mechanical engineer over here. He'll be carrying out the MEPF part. Tanveer sir, are you there?
Yes, thank you, Vatsal.
So you can just
I'll
carry
just
on.
share my screen.
Yeah, I'll just stop share.
Yeah, sure. Thank you. And please confirm once it is visible.
Yes, sir, it's visible.
Okay, okay. So, so for MEP, for any engineers, whether we are from HVAC or electrical or fire or plumbing, we need to start our workflow. So the workflow is once we have received the file from the architect, since this is a single software, so we need to take appropriate template for it so that we can start our work. So for this, let's suppose if we are starting from scratch, how do we start our workflow? So, so you can simply browse and you can select your template. Accordingly, we have different templates for different disciplines, like shapes are explained for default metric, for architecture, for we have electrical, for electrical, for fire, then we have plumbing as well. So different templates. So let's suppose I'm taking any mechanical default metric for HVAC templates. I'll click OK. Now I can have a template. So once we have taken the template, so the first step, the workflow is what we do. We don't start working in the architectural file itself. We have to link this file. It's like XREF. So we'll be linking those architectural file for a reference. We'll be acquiring coordinates from them, and then we can work, and then we can create our views also. So this is, let's suppose, if I'm taking any views, so I'll just quickly show you the workflow here. We'll be bringing those the architectural file. So the architectural file which we have received, so I'll just browse it here. So sample project, this is the architectural file. Here we will be deciding what will be the position of this file. Okay, so this data will be getting from the architects, whether it will be by shared coordinates or internal origin to origin. So I'm considering internal origin to origin, and I can go ahead with this. So if I select this model, so this will act as a single entity. It's just a reference file. It's a complete block. So once we have linked this file, we can pin it so that it doesn't move. Okay, so once it is pinned, we can go and we can collaborate with the architectural file, because this file will be receiving, in multiple times, and we might receive some changes also during the process, and we might get some updates as well. So that is why we need to make a coordination with the architectural discipline. So that is why we do what? We copy and monitor this model. Okay, for copy and monitoring purpose, I'm going to copy multiple and monitored all those levels, so that I'll make sure that if any changes are done in the levels itself, so I'll be notified. So Revit will intimate me instantly if I'm changing it. So I can make sure, so levels I have selected. So these levels are not just copied. These are not just copied, they are also being monitored with each other. So this is kind of a coordination with the architectural discipline. Okay. So if I show you, let me just change this reference plane turn off. Yeah. So see, these are the two levels actually. And if I show you, so you'll notice a small monitoring sign is there. Okay. Here it is. A small monitoring symbol is there for each level. So that means the next time when we receive the updated file from the architect, and let's suppose he has changed this levels, so we'll be notified instantly here. So even if I slightly change my levels here, the kind of error which I'll be getting, so let's see, coordination monitor alert level moved by 200, and it will be going to be within that project also. Okay. We can anytime we can change within the coordination review. I can select link and I can check it. So this is what we have done. So what action do I want? Let's suppose we have done with the HVAC part. We have done with the uh, duct layouts, and levels have been changed. So what action do I want to take? Whether I want to postpone, whether I want to accept, whether I want to move the levels. Okay. And I can add the comment also here, and I can create a report out of it. I can share it over mail as well. So this is a basic coordination which I wanted to show you. The next, I'm not saving this as a project. I'm just closing it. For HVAC, let's suppose if I want to create any model here within this project. Okay. So I can go with this. I can place some levels here, some diffuser, some air terminals. So within system tab, we have all the tools here. Okay. So let me just create a system here. I can place some supply diffuser at finish floor level. This is at 2438. So I can take these levels 2438 here, and I can place them multiple times like this. And here we have here, here, okay, and here. So these are supply. In front of them, I can place some return also. So even since all of these are parametric families, I can change the size, diffuser width and height, everything. It can be controlled. Their neck size and their face size, everything can be controlled from here. Right next to them, I can place them. So levels I have not given them for this return diffuser. I can select all of them at once, and I can give the level as the ceiling level, which is 2438 actually. Okay. So for creating any duct layout, we can simply, since we are working in a 2D plan, byproduct which we'll be getting 3D, we only need to specify the width of the duct, okay, the height of the duct, and we have a system type, what type of air it will be, which it will be carrying, whether it will be carrying a fresh air, supply, return, exhaust, pressurized. So I can take accordingly here. Okay, and I can provide the middle elevation or bottom of the bottom elevation of this duct. I can simply draw, let's suppose, and I can place some equipment here also. So if I'm starting from here, let's suppose, so after catering this, so if it is reducing till 700, I can go like this. It is reducing also. Automatically, it is placing a transition piece. Then 600, if I go back, see, now after catering this much, I may want to reduce further. And I can reduce here also. Then I'll take 550, 450, and here also. Then I can further reduce to 400. So this is simple. We are doing it. We are just giving some inputs here. And at the end of the piece, I want to just place, I can place a duct end. Okay. This is a dead end here, which I have placed. So this transition also we can control the length of this transition, whether it will be like how much 600, 350, 450. Accordingly, I can control this if I want to. So this is 450. If I want to make it for 600, so everything can be controlled here. 600. Okay. Now, if I want to do the connections here, I can simply connect. I can select the diffuser, connect into, and I can click on this duct, and has been connected. I can do for the entire air terminal, connect into. So you'll see all of these are connected. So once we have connected, we can take a pressure report, we can check for the flow, everything if we want to. If further at detail stage, if we require, we can go for it. Okay, so let me just place our equipment also here. So if I'm placing any vertical AHU here, let's suppose we have an AHU room here, and let me place it on floor plan, and I'll just make it here. So if I want to take out duct from here, I can simply click on the supply. It has a multiple connector. Every mechanical equipment or a pump or a chiller, they have a connector specific to their system type. So just like this, it has a chill water supply, in supply air duct, return air duct. You can also see a P trap here, which is for drainage. And then we have this for electrical connector also. So it is it has a 240 volt, and this is of 14,000 watt of load. So everything is there in detail. So if I want to draw a duct here, so ideally I want to come up till 2900. So I'll come to 2900, and then I'll hit apply once, and I can go like this, and I can come back, and I can connect with it. I can, and it is automatically taking an elbow also. You can control this radius, bending radius of this elbow as per our requirement. We can change it. We have multiple. We can take as per our requirement. So now this has been connected. So if you check this, you can see that here, this is our equipment. I'll just make it consistent color. So we have placed our diffusers also here. You can check it. Connections is there. Everyone. Even if I change it to mechanical, you can check it here. This is how you can create your system. And these are connected. If you want to check your connections also, we can check whether it is connected or not. Yeah, everything is getting selected. It's an entire system. So once we have done with this, we can come back and we can take a report out of it. Let's suppose if we want to go further and we want to check with this pressure or pressure report, or we want to inspect the system, how much air at what part we are getting. Let's suppose this is this diffuser has a flow of actually it has not been, we have not provided, but if I see here, yeah, it is there. So it is 497 CFM. You can check it here. Okay, so everything is here. You can check it here also from till here 497. But if I come here, these two are added. So now the flow is getting added 995 CFM. Okay, so similarly here also. So at any point or any diffuser, you can check. For this diffuser also, we have given 495. We can anytime we can control and we can give changes. Flow rate also. If you want to have 600, you can change the flow to 600. And now if you change, inspect it, so it will be inspecting 600 CFM here. Okay. So since like I said, you can inspect the system as well. And if I want to have a pressure report, I can click and I can create a duct pressure loss report. What parameters do I want? Flow, size, velocity, length, coefficient, and friction. Everything is there. So I'll just quickly generate pressure loss report. I'll just write it and I can save it. And I can open the pressure loss report here. So here you'll see for every fitting is taking from ASHRAE, and you can go for this. For this critical path, it has automatically, this is falling for 1.2 mm. pressure it is for total, for the critical path we are getting. For detail, for every element, here it is mentioning for every part, this much of flow is there, this much of size, this much is velocity, this much of pressure, and this much of the length of the duct. See, so total we have added. So these are for fittings and accessories as well, if we added. See. So for report also we have seen for inspect. So when we do concept stage, we can also create a heat load report out of it once we have received the file from the architectural from the architect. So here I have already taken out the reports. If I click on here, you can see this complete report here. So once we set the location actually, so it takes the data, it's take the like shapes are explain it automatically. It takes the data, the dry bulb temperature, wet bulb temperature, latitude, longitude, everything is there. So I just need to specify the location and weather station that will follow the data. For that remaining data for a space, it is considering by default from Array. Although we can change it as per our requirement, it can be customized. So pick for building summary, type of building, total area, volume, everything you can see. For zone, okay, how much air it is required, relative humidity we can set. Okay, so peak heating airflow this much. Okay, so here calculated result, total tonnage required, you can see total CFM, peak cooling airflow in CFM. So internally we can change the unit as per requirement, whether we want the flow rate in liter per second or CFM. Everything can be customized as per our requirement. So you can check with this reports. Or so this is the entire which has been taken from the software itself. Okay. So I'll just quickly change it, the slides. So here using this project, we have seen how we can create for different systems also, which I have already shown you. Okay. For side diffuser, these are for connecting with water source heat pumps. We can control the flow, everything. You can check it here. Different sizes you can place. And since all of these views and schedules are integrated, you can change it accordingly. If you change anywhere in schedule or any view, it will be reflected in other views as well and schedule. Right. Right. This is all. The different duct types also we can accordingly select. This is mited elbow tabs. Earlier I showed you radius elbow tabs. It is having a fittings, whereas I had a tabs fitting. So different type, whether it is oval, round, rectangular, we can select. And it is a separate routing preference also. What type of preference do I want? Elbow, transition, wise, single wise, double wise, so everything. Like you can check it here. Right. This is how to make connections also. This is a mechanical setting. We can set this for automatic layout also. For concept stage, we can just provide, we can select the duct type, and at concept stage, we can create an automated layout. Automated. We just need to place our fixtures, air terminals, and equipment. It will suggest multiple layouts, and accordingly you can choose whichever feels like convenient, more appropriate. Okay, so here we can create systems also. Like if we go for detail stage further, so we can create system name, provide also, and we can go with this. We can one more thing we can do, we can go for this duct sizing also we can do if we require, and it can be done both ways. See, this is the automatic layout it is suggesting here. Different, so it has different solution. If you change whatever you feel like, you can check it, you can entirely, and it will convert it. You can edit this layout also as per your requirement. See, let's suppose if I stretch it down, see, and this shows the default solutions here. So this is kind of at concept stage. This is automated layout we can create. So Currently, we are getting 6 solutions here, out of which for different types. For custom, we have 1 of 1. You can finish and it will automatically generate the duct. So this is usually done at concept stage, okay, where we are not much concerned of sizes and all. Yeah. Once we have done with this layout, we want to go for the duct sizing. So here also we can choose whether we want to do the sizing as per velocity or friction or both also, or a static regen. So we have an option, and we can restrict whether we want to change in height only or width. So all those things can be done here. We have an option, calculate size only. You can click OK. It will change the sizes of the duct. See, the sizes have been changed as per the velocity. There might be some, manual intervention required, which you can do later also. Okay. For plumbing also, we can provide pipe. We can similarly, just like we have created duct, we can create pipes as well. We can provide slopes to them depending upon our requirement, how much slope do we want, and we can create pipe. So for piping also, you can see we can select the segment, okay, whether we want to go for a chill water pipe. So we can create schedule called mild steel, carbon steel, okay, everything we can create. And for PVC also, we can have our own, different PVC fittings, everything we can control. We can do the piping connection. So just like this, we can take this dia of the pipe, system type of the pipe, and we can do the connections. So here you can check the slopes also within this pipe. How much slope it is showing 1%. If you want to change it, you can change the slopes as well. And the unit of slope also you can change as per your requirement. Yeah. So internally, any units you can change from percentage to per mile, you can change it. For plumbing connections also, we can do the connections. Dia of the pipe, we just need to provide elevation, offset, and system type, whether we are creating a water supply or a drainage. So here you can see we are creating a domestic hot water, and we can connect with them.
Hi, Tanvir.
Yes.
I think we can go a little bit faster.
Sure, sir. Yeah.
Conclude maybe in like next 5 minutes.
Sure.
Thank you.
Yeah. So this is what we can do with the piping. Here you can see this routing preference also. Pipe segments, every fitting is there. T, junction, transition, everything we can control as per our requirement. So different fittings are also there for like pipes like welded fittings or flange fittings or groove coupling. Everything can be done. We can download if we don't have the family. So many of the manufacturers like Ashirwad, Victolix, Vikings, they are creating their fittings also. We can simply download and we can load it into our project and we can create. These are for this pipe accessories for different valves we can place, whether it is for plumbings or HVAC or fire. So pumps we can different, like you can see we are placing a check valve. We just need to it will snap the size of the pipe actually. So you just need to place the size. It is going to snap it. For butterfly valves, any valve depending upon, you can check it. It has been placed. So it has entire library of valves also by default. You can use it or you can download it from also. And definitely you can create yourself. Pressure gauge, temperature gauge, you can see. So these are the different fittings which are from the manufacturer. You can load it. These are the lighting fixtures. Okay. which you can download their families. You can use it into your project. Different families. Okay, the sheets we can create. This is the quantity, duct quantity we can calculate. Okay, electrical panel schedule we can also have. We can create your panel schedules for every panel. Before we go, just I want to show you the 3D of every discipline here. You can come back and the reports and schedule which have been reported. This is the electrical model of this project. You can see the conduits are there. Okay, fire alarm parts, horn strobe, lighting, pictures. You can check it. Okay. Similarly for HVAC, I have segregated 3Ds for different models. You can check with this HVAC. We have water source heat pump. Everything is there. For plumbing pipes also you can see, check with the fitting, P-traps, everything. Okay. For plumbing, if I show you separately, you can check with this. And you can see the WC has been connected. Flow drain, wash basin. Check with this pipes also. If I show you the coordinated view of this is the entire coordinated view of this project. The plant room here. So now I'll request Tushar, who is role playing of project coordinator. So I'll request Tushar.
Okay,
You can
thank
take care from here.
Yeah,
Thank you.
my video is not sharing.
Let me. So I will stop my screen.
Okay.
Yeah.
So I'll be sharing my screen. So I hope my screen is visible.
Yes, Tushar, it's visible.
So I'm playing the role of a design consultant. So let's assume all the three disciplines, the architecture discipline, the structure discipline, and the MEP discipline, they have given me their own completed models. So this model which you are seeing on screen is from the architecture discipline. This is a complete architectural model. It doesn't have the MEP or the structure elements yet. This another model. This is a structure model. Let's say this is from Vatsal. He has done everything, the rebarring and all. All the columns are there, footings are there, as you can see. And the last model is from Tanveer, from the MEP team. So this is a complete model, the combined model of the MEP services, where all the ducts, HVAC is there, and all the plumbing pipes is there. So now what I'll do is I'll open my Navisworks software over here. This is a BIM software. So this is used for checking the clashes. So the idea here is that we can detect the clashes in software itself, and we can resolve them in the software itself, than to resolve them on the site, which will be time consuming, and a lot of money will be spent over there. So to save our time and money, we can check the clashes if there are any clashes between the disciplines, the three disciplines. So we can check it over here. So what I have done is I have created a NWC file. So we have a external tool for that. We can go to add-ins and we can quickly convert, clicking on Navisworks. We can click the make the NWC file. This file is very light in size. The size is up to 80% reduced. So I'll append the files over here. So these are my 3 NWC files. So I'll quickly open them together and I will get the combined model. So once it is combined, I'll show you that all the pipes are there, the columns are there, and obviously the architectural elements are there. So you can see these are the MEP elements over there on the terrace. And you can even see the pipes over here, which are perfectly fitted into this project. So you can see these pipes over here. And over here, you can also see the structural elements, which are there inside this curtain wall. So now there is a selection tree. So I'll open this tree. So these are my 3 NWCs. You can see the architecture NWCs at the top, then the MEP NWC, and then the structure NWC. So these are, if I select the architecture NWC, all my architectural elements will get selected. They will turn blue. If I select my MEP NWC, so I'll show you that these pipes have gotten highlighted. They have turned blue. And if I select my structure NWC, my structural elements get highlighted. You can see these footings are getting highlighted. So now I want to show you that clash detection is very quick. In just a few clicks, you can do the clash detection for all between all three disciplines. So I'll click on this clash detective option. I'll go to add test. So let's say I want to check the clashes between the structure and the MEP discipline. I want to check if some beam is intersecting with some HVAC duct, or if some pipe is intersecting with some structural wall. So let's find out. So I've added this test. This is structure versus MEP. And now I'll select my structure NWC over here in the selection A, and in selection B, I've selected my MEP NWC. And now I'll click on run test. So you will see how quickly it detects the clashes. So as you can see, we have 886 new clashes. So if I slide it a little, make this window a little smaller. So you can see this is a structural wall, and this HVAC duct is passing through this structural wall. So this is a structural wall and it's a clear clash. So you can see this clash. This duct is passing through this structural wall. So I'll show you some other clashes also, 2-3 other clashes. So you can see this particular pipe is passing through these beams. So there are no sleeves which are provided for this pipe to pass. So we need to provide sleeves for in the structured, or you need to change the pipes, the route of the pipes to incorporate into this particular design. Same way, if I go further down, so here is another clash. So you can see this little pipe is clashing with this structural slab. So we need to resolve all these clashes. So it is very easy. So what I will do is, I will select these clashes. Let's say I want to go with select the first 50 clashes, and I will assign it to Tanveer sir because he is the MEP consultant. I'll click on this assign button and I will write his name. And I will add a note, please resolve. And I'll click on OK. Then I can generate the reports. So it's very easy to generate reports. I'll click on this report and I can click. We have some various different formats for the reports. So you can see this report format. So I have various options. I have XML, HTML tabular, text as viewpoints. So we will go with HTML tabular. So I'll click on HTML tabular and I'll click on write report. So to save time, I have already saved a report. So I'll show you what that report looks like. So I'll open that report for you and I'll share that report. So that report will include the date and time, at what time and what date the clashes were found, and what were the clashes. Along with that, we have the element ID. So what will Tanveer do? He will search that particular element ID in Revit, and then the particular element will get highlighted, and then he will resolve the clashes. But he needs to link the structure model along with it, and then the architecture model as well, and he will resolve the clashes so that it doesn't clash with any architecture or the structure model. And then he will produce a NWC. He will again convert the MEP model into NWC file, and then we have to again run the clashes to see if the clashes have been resolved. Also in the report, you can see that we have a snapshot of the clashes along with the clash ID. So you can see that this is a pipe which is clashing, and over here, okay, these are all pipes, and then this is a duct which is clashing with the structural wall. So it's very easy to find the clashes between the different disciplines, and then to resolve them in the design authoring software, that is Revit. So that's how the clashes work. So that was all from my end. So I'll hand over to Shitanju sir. Thank you.
Thank you so much, Tushar. Thank you so much everyone, the entire BIM team, for taking us through the workflow of how a project goes from architecture to structure to MEP and then design coordination. So, Tushar, I think you can stop sharing your screen. Yeah. So now we can open up the floor for any questions. We invite all the officials. If you have any questions, you can unmute yourself and ask the questions, or you can put it in the chat box. And meanwhile, just a friendly reminder that the session which was to be conducted tomorrow on Sunday has been cancelled. So the next session will now be conducted on Monday at same time. Yes.
Good evening, sir. Is this software available freely?
No, sir. So those are still in discussion with the head office. So, but these softwares are commercial license, commercial software, and that is a separate topic, sir. But we're under discussion. How do we enable and train your team around these
How
softwares?
to train it now for training and other purposes? We are not
So
having
yes,
repeated bit more.
that is the next step, sir.
Hmm.
The first step was to make everyone aware about the BIM processes and the workflows. The next step is training, detailed training, level 2, level 3 trainings, which will be conducted for all the officials as per discussion and as per the approvals, whatever is required for this.
Okay. Now this all up to 15, the this repetition of the same, is it going to happen or?
So for all the sessions which are going to happen in this round, so these are all going to be repetition of these sessions, sir. Today's
Okay.
session.
Okay. Right, sir. Thank you.
Yes, sir. So we are conducting this session for all the officials. So as per the convenience, whenever they're available, they can join this.
Thank you. Thank you.
I think there is some issue regarding the mute. I'll just check it. Shoaib, can you check, please? I think the people are not able to unmute themselves.
No, sir. Everybody will be able to unmute themselves. Let me help this particular person. No issues. Okay. Can you raise your hand, sir? There's an option to raise hand so that I can, pinpoint you because you have a common name with others. Yeah. You'll get a notification now, sir. You can just click there and now you can speak. And if you're speaking, we are not able to hear you, sir. Although you are unmuted, but you may check your voice inputs from your device as well. Hello? Yeah, your voice is... Yeah, now we can hear you. Hello, sir.
You can hear me. Yeah, I
Yeah.
think even video, I can't start my video. You can't start your video because the host has stopped it.
Okay, although we have not stopped it, but again, I'll just send a notification to you. You can now
Yeah,
press on
okay,
that
okay,
notification.
okay.
And you can start your video as well.
Yeah, so, okay. Yeah, I think
But we cannot see
today
you,
we're
sir,
going
still.
to...
Only black screen is shown. We cannot see you. Please check your camera
Yeah,
inputs. If there is any,
So you can go ahead and ask your question, please.
yeah, you can go ahead.
yeah,
No issues.
it is there. Yes, it is there. Yeah. Shitanshu, actually, I had no question. Only thing is that I wanted to close this formally. If anybody
Okay.
has any question, please put your question.
Okay.
So today only 66 people attended it.
Okay.
Far below than our expected number of say 200 odd, which we had yesterday.
Mhm.
So any question from participants? So this all was done in the Revit 202 version. They have all the inbuilt other software available for MEP for other services also. So we'll continue this session, same session on Monday, Tuesday, Wednesday, Thursday. For more demo. Whoever has not registered, they may get registered today, tomorrow, or tomorrow. So Monday's time around 2:30 p.m. we'll have it for 2 hours. So I hope it was a very informative session. Though, and the beauty of this session is that everything was done in the live environment. It was not a pre-recorded kind of thing. It is what not. I hope it is what. It was not a PPT mode. It was all live things. You can see all the different modes. So whosoever has worked a little bit in the AutoCAD, he can appreciate and understand the way people were doing it. So I hope that at least it gives a feeling of some confidence that you can also do, provided you are given this software, access to this software.
Yes, sir.
So anybody from audit side, any senior officer, ADG, chief engineer, sir, if anybody is there, please unmute and speak and say a few words. Okay, yesterday we had STG headquarters, Sri SP Chaudhary, sir. I think today he could not join it. And what I could see even yesterday and today, there was some change in the content also. So it's good to see, I mean, twice. If people have time, they can also join on Monday. It's not a restriction.
Yes.
You learn only. You get
Yes.
some feeling. It is because not it's a pre-called thing. You get a new perspective to things because time is limited and doing everything in 2 hours is really difficult. Creating architecture model, then your structure model, then MEP and HVAC. Beautiful thing. You can have flow details. You can have everything, even your orientation, set analysis, solar analysis. Everything is so. I mean, very nice to see all this. So Sitansu, you may conclude it. So I thank all your team, Soeb, wonderfully, Tushar, Tanveer, and Vasal. Everybody is so proficient in doing it. So I recall my old days in 1995. I was in Tata Motors and I used to do some jig and fixture design in Autodesk, AutoCAD. So I recollect, and really, it's very important to have library.
Yes,
It's
sir.
important to have templates available for doing it.
The processes are very
So
important to be
all
set
this.
up. Yes, sir.
Yes.
Yes, for all this. So thank you so much, sir. We really appreciate your support in conducting this session. Without your support, this is not possible. And our objective is also to make CPWD one of the premier organizations, I would say the best organization for construction in India, also the most technology advanced organization is with respect to BIM. So our team, we will be there, whatever is required to do it, whenever it is required to do it. And any of your team members are more than welcome to contact us and take whatever support is required to help them move on one step at a time.
So after this preliminary, after this awareness program, we'll be having, I mean, detailed workshop kind of thing at our academy at Ghaziabad. So that may happen sometimes in the third week of September. So I mean, full day seminar will be okay, or maybe 3 days will be okay. What is your call
So
on
you are
this?
asking us?
Yes.
Sir, I would like to discuss this in person with you. What are the different options? We can give you multiple options, and then accordingly, sir, you can decide whatever works for you. So we can give you
Yeah,
pros and
actually,
cons of
I
both the
had
options.
visualized. Actually, I had visualized this training in 4 parts. One is the awareness program. Simply, this is the one thing. Second is the little detailed program. In the detailed training, again, you will be showing this, that, everything. And the third one, hands-on training. There will be team of say architect, engineer, civil, electrical, both, and doing some kind of project in their own region which they are having. A
Yes, sir.
small project. And fourth, I visualize train the trainers. Once the softwares are available with us, we can train some of our people to train other people on it. So that is how I have visualized. Let us see how things can unfold. So thanks everybody, all who have attended, and team from Autodesk. So thank you from my side. Anything, if you want to add anything, say anything, please go ahead.
So you have said everything, sir. We are at your command, whatever is required to be done. So I really appreciate again, sir, for all your support and all the team members who are present here on Saturday also. And next week, we hope we have more people joining in across India. Please pass on the messages to all your colleagues or fellow officials to join in on these sessions. These small sessions will be very helpful to understand the basics of BIM and what it is and how it is going to change the future of your projects. Thank you, sir. With this, sir, I would like to take a
Okay, good.
close of this meeting, sir.
Thank you.
Thank you.
Thank you all.